All right, welcome everyone. Thanks for joining this webinar about building reactive applications with the Typesafe platform. I'm James Ward. I'm a developer advocate at Typesafe, and today what I want to go through is how we build applications with the Typesafe platform, build reactive applications. So our agenda for today is to talk first about reactive applications, what that is, and then talk about the Typesafe platform and what that is. And then I'll show you how to get started. We'll walk through building an actual reactive application, and then we'll end with some Q&A. If you have any questions or problems during the webinar, feel free to post those in the chat window, and Laura will help you out with that. So with that, let's dive in. So software is becoming reactive. What that means is that we're embarking on a new way to build software, a new category for software. And the term that's emerging across a bunch of different ways to describe reactive is just the term reactive. There's terms like non-blocking, asynchronous, there's event-driven, and we feel that all these are kind of coalescing into one new software category called reactive. So reactive has four main tenets to it. First, it's interactive. That means that it reacts to users. It's also resilient, meaning it reacts to failure. It's scalable, so it reacts to load. And all this is based on a foundation that is event-driven, which means it reacts to events. So all four of these tenets really tie together. For instance, a reactive interface, an interactive interface, is event-driven. And it requires an event-driven foundation to be resilient and scalable. And so these are the four primary tenets of reactive software that are really changing the way that we build our software. And what's now kind of emerging is new ways to actually build reactive software. There's a bunch of different technologies out there for doing it. There's things like Microsoft Reactive Extensions and a number of other JavaScript libraries for doing reactive. So reactive is something that's certainly emerging across the whole software landscape. What's interesting is how reactive connects to some things that are driving us to change the way we build our software. We've seen HTML5 and mobile become the new way to deliver interfaces to our software. We've seen real-time just being integrated into everything that we do. Big data and NoSQL are certainly changing the way that we do storage. And then we always want better productivity and performance from our software. So the common thread across all these changes is that all of these things in some way are going reactive. For instance, with mobile applications, you see that mobile applications now, they work offline. They also are being able to be pushed data in real time and be kept up to date when you're connected so that your application is exactly in sync with your backend data. Also, we see sites like GitHub where when you are interacting with an issue on GitHub, it's automatically updating the UI when other people are updating the issue as well. And this just becomes an experience that seems like the way that software should have always worked. The reason why it hasn't always worked this way is that we haven't always had the tools to build reactive applications. And so now we finally are beginning to have the tools, and so that's what we're going to be talking about today. So I'm not going to go into all the details of reactive. What we've done is our CTO, Jonas Bonner, along with a number of other thought leaders in the industry, have created something called the Reactive Manifesto. You can find it on reactivemanifesto.org. And this is really an in-depth look at what this new category of software, what this new reactive space is all about. It's written in a technology agnostic way that could be applied to really any technology set. So I would really encourage you to go check out the Reactive Manifesto and sign it if you agree with it. We already have over 700 signatures there. So that's reactive. You're also going to see reactive weaved in throughout all the code that I'll show today. You'll see some of that, and then we'll actually dive into some of the details in a little bit on how you actually build reactive applications and the different ways that you actually implement reactive. So let's talk about the Typesafe platform and how that relates to building reactive applications. Typesafe has built a platform that really ultimately is for building reactive applications. So there's a number of pieces to the Typesafe platform, but before we get into those, one of the primary goals of the Typesafe platform is to provide the productivity of a Rails-like environment combined with the performance of a Java environment. And this is something that's always been a trade-off in the past. You could either choose to be productive but lose some performance, or you could choose performance and lose some productivity. And with the Typesafe platform, what we've done is make it so you don't have to have that trade-off. You can get the best of both worlds. Sounds kind of too good to be true, but you'll see in a little bit from my demos that it actually is true, and people are doing it today. So if you want to get started building applications, the path is that you want to go reactive and you want to build HTML5, mobile, real-time, big data, NoSQL. You want better productivity and performance. So there's some kind of driving force for you to want to go reactive. And then you'll create a new application. There's a number of different ways that you could do that, but we've created a tool called Typesafe Activator. It's currently in developer preview. And in Activator, there's a number of template applications that you can use to start learning about Reactive, dive further into each of the technologies in the Typesafe platform. And so we'll use Typesafe Activator today so that you can see how to get started building applications. And then the tools that you build with are really the JDK ecosystem of tools. So there's the language Java. You can certainly use that. You can also use the language Scala. You can use libraries and other tools that are just part of the JDK ecosystem. So this is one of the great things about the Typesafe platform is that we built on the foundation that already exists in the Java world. We're not starting from scratch. Then when we deploy our application, we'll deploy it on the JVM. And so this gives us the great performance of the JVM, the proven resiliency of the JVM. And then we'll use two other parts of the Typesafe platform, Akka, which manages concurrency and manages everything that we do underneath the covers to actually run the application. And then on top of that, Play Framework is the web framework that handles rendering web pages and doing REST services. So that's the typical path for how we get started with the Typesafe platform. And you'll see me walk through all this in a few minutes. Before we get there, I wanted to give a little bit of an overview of the core technologies in the Typesafe platform. So first, there's Play Framework. It's a high-velocity web framework for Java and Scala. The core feature of Play Framework is that it's developer-friendly. It really aims to make you productive. In a typical Java web application framework, the cycles for testing your changes and seeing your changes are very long. You have to recompile, you have to rebuild a WAR file, you have to redeploy your WAR file, sometimes you have to restart Tomcat. And what we've done in Play is to make it very developer-friendly where to see your changes, you just hit refresh in your browser, and then you see the latest version of your code. So it makes for very fast iterations when you're building your application, which leads to much better productivity. And then there's a number of other tools that help you build your application as well. Things like type safety, being able to build your applications on top of Java and Scala, which are both type-safe languages, that really leads to better productivity. Also leads to being able to manage large code bases much more easily and not have to deal with the pains of dynamic languages and when those code bases get large. Also, there's built-in testing tools, great support in IDEs with both Eclipse and IntelliJ. Play also supports the modern web and mobile space. So for instance, Play is just RESTful by default. So you don't have to kind of strap on REST on top of the web framework. Play by default is a RESTful web framework. So it also has JSON as a first-class citizen, which makes it really easy. If you just are building a web service and have no UI, then great, you can do that in Play. If you want to do traditional server-side templates, you can do that in Play. Also, if you want to use an asset compiler, so if you want to compile and minify your JavaScript, or compile your CoffeeScript into JavaScript, or compile your less and minify your CSS, all those things are just built into Play, those asset compilers. So it really rounds out the whole workflow of what's being called single-page applications. So you can do both the back-end JSON service and the front-end JavaScript, HTML5, all in the same environment and have the same experience as you're working on both sides of the application. Also, Play supports WebSockets, comment, and event source for being able to do push out to the client. And then there's pretty extensive support for NoSQL and big data through some libraries that you can easily plug into Play. And then one of the core parts of Play is to be able to scale predictably. By building on top of a stateless web tier, you can scale Play out horizontally. So you can just add in new nodes into your architecture to be able to handle more requests. Play also supports non-blocking I/O. It's built on top of Java and I/O to be able to avoid the traditional thread per connection limit. This has traditionally been one of the major bottlenecks in our software, is that we are tied, every connection requires a thread, and that's an expensive thing to do. And so by using Java and I/O, we're able to avoid that overhead and do things much more efficiently. So that's a quick overview of Play. We'll actually dive into some code in a couple minutes. So Akka is another key piece of the Typesafe platform. What it's about is managing concurrency and distribution. It's resilient by design. So it allows us to have supervisors that can monitor and watch for failure and figure out what to do when failure happens. Also, Akka is high performance. It can support sending millions of messages a second. And the actor model used by Akka is has a very small memory footprint. So you can spin up millions of actors in a traditional heap size on a JVM. And then Akka is built to distribute. It's built to be able to be decentralized and clustered. So you can actually cluster your application and route messages across the cluster, and all of that is now just built into Akka 2.2. So then Scala is a language that's part of the Typesafe platform. It's an optional language with Play and with Akka. With Play and Akka, you can use Java and you can use Scala. It's up to you. But Scala is really it's really the first programming language created as a reactive programming language. It's created to support the reactive paradigm of programming and created to support asynchronous by default. So there's a number of language features in Scala that make it a really productive language to write code in. Things like type inference means that you don't have to always be specifying your types all over the place. You let the compiler figure that stuff out. Also, it has seamless interoperability with Java, which is really great for when you have existing Java libraries that you want to use in your application. It has support for things like higher order functions and pattern matching and traits. There's really powerful language constructs that will make you a more productive developer when you're using Scala. So again, it's optional. I'm going to show both Java and Scala today. So that's the core of the Typesafe platform. I want to go through some of the tools that really round out the tool chain as you're building out reactive applications with the Typesafe platform, and show you how we integrate with other tools in the ecosystem. So first, Eclipse has a plugin for Scala and for Play. IntelliJ has the same. But our language and our platform works really well with just plain old text editors also. So if you're using Sublime Text or some other regular text editor, VI is my personal favorite, then the Typesafe platform will work great in that environment. I'll show you how you can see error messages in the browser and not have to have an IDE tell you about your errors, which makes you productive no matter which coding environment you choose. For testing support, it's really all the normal testing tools that you have in the Java ecosystem. So JUnit is the really typical one, but then in the Scala space, there's Scala Test and Spex2. There's great performance testing tools like Gatling. And so really anything that you have in the Java ecosystem is available to you. For build infrastructure, we use SBT as the primary build tool, but there's also some support for Maven and Gradle if you're doing Scala and Akka as well. And then, of course, we support running continuous integration in Jenkins and Bamboo and even Travis CI. So the normal workflows that you have for doing TDD, for doing CI, for doing continuous delivery, all those are supported in the Typesafe platform. For deployment, we take a bit different route with Play than you may be used to. We use a containerless deployment model. The reason for that is that it really supports the continuous delivery model that most people are moving towards. And so what that means is that to actually run your Play application in production, you don't have to deploy into a container and deal with that whole cumbersome process. You just take your Play application, you copy it to a server, and then start it up, and that's it. This is the traditional way that everyone outside of the Java ecosystem manages their deployment, and so that's the way we do it in Play. We feel that it really leads to higher productivity, much easier way to do like canary deployments and rolling upgrades and schema evolutions, those sorts of things. So, and it's of course supported on all sorts of different cloud providers and many different infrastructure providers. So if you are using Amazon Web Services, that's great. Play works really well with that. You just copy up a zip file or create an image with your favorite tool for doing that, and then do your deployment and scale up your number of instances. So that's how we do deployment with Play. With Akka and Scala, you could, of course, fit those into whichever model you want to use for how you do your deployment. Play includes Akka, so if you're doing Play with Akka, then your deployment would be the Play containerless way. So then for monitoring, there's a number of third-party tools that support the Typesafe platform. Also, the Typesafe console is a tool for monitoring your actor systems in Akka. And then tools like New Relic, Akka, and App Dynamics all have support for Scala, for Play, for Akka as well for doing monitoring. So I wanted to point that out just to give you an idea of the ecosystem around the Typesafe platform. If you're already in the Java ecosystem, it should be very familiar to you. It's not a whole new world. We're just building really on top of the tools that have been there and have evolved over the last 15 years or so. So with that overview of the Typesafe platform and Reactive, I want to actually dive in and show you a reactive application, show you how to get started building a reactive application. So as I said, Typesafe Activator is really the easiest way to get started and go reactive. And so what you'll do is you'll just go to typesafe.com, you'll click Get Started, and then you can download Typesafe Activator, and then you can create a new application. Activator is a local running web application, so instead of running it in the cloud, you run it locally on your own machine. So most developers are more comfortable with having their code on their machines, and so that's the model that we support today. So let me actually just go start up Activator so you can see how this works. So I've downloaded the Activator zip file and extracted it to my hard drive, and now I can just launch Activator. Of course, this works on Windows, Mac, and Linux. And what it will do is start up a local web application, of course, built with Play and Akka and Scala. And then here I am in my browser. Now this is the Activator UI. So I can either choose to open an existing application or I can create a new application. If I choose to create a new application, I can choose from a number of different template applications to start with. So there's the default kind of out-of-the-box template applications. One of these is Reactive Stocks. That's what I'm going to use today. But then you can also browse a number of other templates. The community has been contributing templates as well, so there's some templates in here from us and some templates from the community. So let's select the Reactive Stocks application. It'll give me a default name for my application and a default location. I'm going to change the location to be on my desktop instead of in my home directory, and then I'll hit Create. So now this launches me into the app management screen for the Reactive Stocks application. There's a number of things that we can do once we get into the app management screen. The first that you may want to explore is the tutorial. Every one of the templates in Activator comes with a tutorial that will walk you through the code. It'll walk you through the different parts of the application and how it works. So you can just step through the tutorial. This one will tell you about the Reactive Manifesto and reactive push and reactive pull and all sorts of different aspects. So you can read that on your own. It's a great way to learn about building reactive applications. But I want to walk you through a bunch of this stuff live. So first, let's go to the Code tab. So in the Code tab in Activator is where we can browse through the code for this application. So as you can see, Activator is just this web-based interface for being able to browse my application. We also can see the compile, run, and test output of the application. And so in here, we can start to look at some of the codes. If I go into app and actors and go take a look at the user-actor.java, we can see the code right in my browser. I can also edit the code right in my browser. But most users who have gone beyond the learning part will probably opt to actually open this up into IntelliJ or Eclipse, and that will actually generate the project files for your IDE and then allow you to open up the project in your IDE and work in it that way. Most of the time when I'm working on an application, what I'll do is I'll be in my IDE editing code, but I'll leave Activator running so that I get the nice compile, run, and test output here. So one of the things that Activator will do is whenever you make a change to the code and save a file, it'll automatically recompile the application and then deploy the application essentially, and then rerun the application's tests. So let's go step through the other parts of the Activator UI. First, there's compile. So compile is just the compiler output from this application. So this is where you would see compile errors for the application, that sort of thing. And then the Run tab is where I can see the output from running the application. If I'm running a server application, then of course it's going to be listening on a port. And so I can now go open up this application. So now this is the actual Reactive Stocks application, the Play application that was created from that template. So the Reactive Stocks application now, it's also running locally. And now I'm seeing in here the Reactive Stocks app. What the Reactive Stocks app is pushing simulated stock data from the server down to the client through a WebSocket. So I can see this data streaming out in real time to the client being rendered in a chart. I can also, that's showing reactive push, and we'll get into more details on that in a minute. But I can also take one of these stock symbols and flip it over, and what this will do is make a request to get the tweets about that stock symbol, and then once it has all the tweets, it will then do a sentiment analysis on each of the tweets to determine whether we should buy, sell, or hold the stock. And you'll see this request is taking a little bit of time. The reason for that is the service that we're actually hitting to get to the tweets actually simulates failure about 20% of the time. And this is an important part of Reactive, is to be able to be resilient and react to failure. So we did finally get the tweets, and the tweets say hold. Let's try Oracle and see. It looks like hold Oracle as well, and Apple also hold. So nothing too interesting going on in the stock market today, I guess. But and please don't take the stock advice of the Reactive Stocks application. It's a sample for demo purposes only. But it's kind of a fun way to illustrate Reactive and the different parts of Reactive. So we'll go through some of this code in a little bit. So there we go. There's my running application. I can see any running output here. If I'm not doing a server application, if I'm just doing like a standard Hello World or console Scala application, then I would see the run output from that type of application here in the Activator Run tab as well. And then the Test tab here, this will show us the output of actually running the tests on this project. So this project has 7 tests, and you'll see that all 7 of those are passing, so that's good. If I were to go in and make a change to a test, let's actually go give that a try. So if I go back to my test, and I'm going to make my test fail by changing my test, which is maybe not the best way to do this, but let's see if we can now, once I save that, see if we can get it to fail the test. So it might take a couple tries, but here we go. Once I've saved it, now it's rerunning my test. So, yep, there we go. So we got 1 failure. So 6 passed, and then that one that I just changed looks like it failed because the price was not within the threshold that it expected because I tweaked the test and made it fail. So let's go back and change that so we can get our test to pass again. So I just can make a change there in my browser and save, and then it will rerun the tests, and then all of my tests should now be passing. So this supports really a test-driven development type of pattern where I'm writing my tests, I'm writing my code, and able to instantly see the output of my tests. Everything that I'm showing you here in the browser with the Activator UI can also be done through a command line. So if you're more of a command line person, that's great. If you want to run the test from the command line, just like is happening here, you would type Activator space twiddle test, and that would continuously run the test whenever you make changes. So Activator is really just a UI on top of things that you can also do through the command line. So let's take a deeper look into this reactive application and see the different parts of this application that are reactive and how we actually implement reactive in this application. So let me hop back to a couple slides here to help explain this. So reactive programming can be done in a variety of different ways, and there's different types of reactive. So let's start with a reactive request. So a traditional request when I make a request from, let's say, my web browser to the server, then it's going to consume a thread to handle that request even when that connection is not active. And what we want to be able to do in a reactive world is be able to not tie a thread to the connection so that when the connection is not active, I can give the thread to someone else and let it process something else. So that's a reactive request, is when we do a non-blocking and asynchronous request. But there's also a way to be able to not just do a non-blocking and asynchronous request, but be able to compose them together. So reactive composition is being able to do a number of requests that are all asynchronous and non-blocking. So let me show you an example of this. We go back to the reactive stocks application. So when I click on one of these stock tickers to get the information on what the tweets say about whether or not I should buy, sell, or hold based on their sentiment analysis, that's making actually 17 requests. Let's pull up the actual JSON service that this is using underneath the covers. So there's the one for Google. So this is the JSON response. So when I made that request to my browser, the first request was from my browser to the Play server. The next request was from the Play server to Twitter to get the tweets. And then once we got the tweets back, then there was, I get 15 tweets back, so then there were 15 requests that went to the sentiment analysis service to get the actual sentiment for each tweet. And in the reactive world, we want that whole entire chain of requests to be asynchronous and non-blocking, meaning that first request that I made from my browser to the server, when that one is waiting for those other 16 requests to complete, it's not blocking any resources or any threads on the system. And then once the request goes to Twitter, again, that happens in an async non-blocking way. So when I'm waiting for Twitter to come back with a response, I've given my thread to someone else. So we get the tweets back, and now we make 15 requests concurrently to the sentiment analysis service, and each of those are now asynchronous and non-blocking. And as soon as all 15 of those finish, then we get another thread back and can send the response back out to the end user. So that's reactive composition. Let me show you how we actually build reactive composition in this application. So this is a Play application, and one of the things that we do in Play is we define the routes that we want our application to handle. So this application, as you may have noticed, the URL is /sentiment/ and then the stock ticker. So in Play, we configure in the conf routes file a mapping between an HTTP verb, an HTTP path, and then the controller that's going to handle that request. So in this case, a GET request to /sentiment/ and then some stock symbol. It's going to be handled by controllers.stocksentiment.get, the GET method there, and pass it that symbol. You also see there's a number of other routes defined in here. So that's great. We have our routing defined. Let me show you one of the really cool things about Play. So everything in Play that can be compiled is compiled. So that's true for the Java and Scala source code, of course, but that's also true for JavaScript and CopyScript and less. It's also true for the routes file. It's true for server-side templates. We try to use type safety everywhere to make the compiler do as much work for us as possible. So let me show you an example. If I come in here and I make a typo in my routes file and I save this routes file, you'll see that now the compile tab is telling me, hey, you got to compile it. I can also, in my browser, hit refresh, and Play will show me that error here in the browser. So this is how you don't necessarily need an IDE to do development with Play. You can just see these errors. The errors are nice, pretty printed errors where it'll show you exactly the line number that the error is on and error message. And so in this case, it's saying, hey, stock sediment, that doesn't exist. So so that's great. We get those error messages. And we will get these error messages in here no matter which compilation error has caused it. So whether whether you have a compilation error in your Java or your Scala or your server-side template or your CopyScript or your JavaScript, any of those errors you'll see displayed here in the browser. Of course, we don't want these code and other things like this to leak out when we're in production. So you only see these compilation errors in the browser when you're running in development mode. When you run in production mode, you'll no longer see these error messages in your browser, so you don't have to worry about the potential security leaks there. Let's go fix that and save. So you also notice that anytime I make a change that needs to be recompiled, As soon as I save the file, it's automatically recompiling that, and all I have to do is hit refresh in my browser, and we'll then see that change. The routes file changes take a little bit of time to recompile because there's a lot of kind of work going on with the routes file to generate reverse routing information and JavaScript routing information and all sorts of other things. But once this compile finishes, then there we go, we see that request complete. So all we have to do is hit refresh in our browser, and we see the changes immediately. And this is true for any code changes, anything that gets compiled. You don't have to think about rebuilding WAR files and redeploying them and restarting Tomcat. You just hit refresh in your browser. Okay, so that's the routes file. One other thing to mention about the routes file is that in the routes file, you define the forward mapping of routing information. The forward mapping is how Play determines, based on an HTTP verb and path, where to route the request. But oftentimes in your application, you need to reference URLs. So for instance, if you want to do a redirect in your application, you need to have some way to get the URL to that redirect. Or if you want to look up the URL to a JavaScript file or something, some static asset, you could hard code those URLs into your application. I've done this in the past, where I'll have strings all over my application that contain routing information. The problem with having strings containing this routing information is that it's not type safe. What Play does is when it compiles the routes file, it compiles it also into a reverse routing table. So then in my application code, if I want to look up the route to something, I will use the compiled type-safe reverse router, so that then if I decide to change my route, the reverse routing table is going to be recompiled automatically, and automatically throughout my application, the new routes will be used, and I won't have to worry about bugs that are caused by missing a route refactoring in some string somewhere. Okay, so that's the route syntax. Let's take a look now at the actual controller that's handling this request. So this is in app controllers. App is the main source directory for my Java, Scala, CoffeeScript, and less source code. And then there's the stock sediment.scala file. So this is the file that's actually handling that request. So you'll see that I have a get method defined here. And of course, I could write these controllers in both Java and in Scala. This one is in Scala. So let me show you how we're actually doing the reactive composition for this stock sediment service. First, we create an action, and an action is something that's responsible for producing a result back to the browser. The result that we're producing in this case, if everything goes okay, is an OK, which means a status code 200. So this is how we, one of the ways that Play really exposes the RESTful nature of the web to the developer. It's not trying to hide the response status codes from the user. It's really trying to expose those so that you have really the RESTful style pattern on top of all this. So then I'm creating this action that's producing a result, and part of this action is an async block. And this async block is how I get to the reactive nature of this request. So an async block says that this block of code contained in the async block, it's not actually going to return a response. It's going to return a future of a response. And the future is the way that we don't block the execution here in this method. So this method will actually execute in probably nanoseconds and return this future of a response. And then that future of a response is the handle that will then be fulfilled with either a result or an error. And so let's follow first the result case. So what I'm doing is some composition here with Scala's for expression, where I'm going out and fetching the tweets. So I go get the tweets. And again, can't really tell here, but this get tweets, actually we could, let's scroll up. Get tweets is returning a future of a response. So again, non-blocking, asynchronous here. And then once we get the tweets, then I'm going to load the sediments for each tweet, which returns a bunch of futures. So there's a future for each of those requests to the sediment analysis service. And then I sequence together all of those futures, meaning I'm going to return one future that aggregates together all those futures. So that's my future that I will essentially put a handle on and say, all right, when this future has a value, when the future has been fulfilled by all those responses coming back, then I'm going to yield something. And what I yield is, first I need to look at the sediments and compose up a result which determines, hey, is the sediment negative, neutral, or positive, and then I turn that into JSON, and then I output that JSON there out to the browser, and that's exactly what we're seeing here. But this whole block actually returns a future of a response. So that's how this whole thing becomes asynchronous and non-blocking throughout the entire chain. So whenever there's something in a wait state waiting for the other side to respond, we take that thread and we give it to somebody else so that we can do something else with it. And then futures also have a concept of being able to deal with failure. React to failure, that's one of the core tenets of reactive programming. And so in this case, what I'm doing is I'm attaching this recover with to the future. And this is attaching to the kind of outermost future, the future that's aggregating everything together. I could also attach recovery, being able to handle the failure. I could attach that to any part of the future chain. In this instance, I'm just waiting for any failure to bubble up to that high-level future, and then I'm handling it. And you'll see that what I'm doing in the case of a failure is I'm sending an internal server error and then creating some JSON to return that. So that's one of the ways that we can deal with failure in this async and non-blocking world. So that's reactive composition. That's being able to take a number of reactive requests, so async and non-blocking requests, and compose them together into a whole entire chain that the whole thing is now asynchronous and non-blocking. It's reactive. That's one example of reactive. Let's move on to the next one. So the next one is reactive push. So in a traditional model, most of us haven't done real-time push in our web applications because it traditionally has been a thread per connection barrier, which means that if we have a thread per connection, let's say we allocate maybe 200 threads to our web application, that means that per server we could get 200 users. That obviously is not a good way to go, will not scale for most use cases. And so the reactive push model is where we take the asynchronous and non-blocking I/O and we apply that to streaming data. And in play, we can do this through 3 different channels. We can do it through a WebSocket. WebSocket is actually bidirectional, so we can do reactive push and reactive pull through a WebSocket. And then for just reactive push, we could also use Comet and server-sent events as well. But it's the same programming model. It's the same way to do asynchronous programming, event-driven programming here. So let's take a look at some of the code for how we do that. So first, let's go back to our routes file to see where we set up the WebSocket. So WebSocket is set up just through a GET request and then it upgrades it. And Play has built-in support for a WebSocket. So I'm saying handle a GET connection to /listen/ some UUID and then call this listen method. Let's go take a look at that listen method here. So that's in app controllers application.java. So here's the listen method here, which takes a UUID. And now what I'm doing is I'm setting up a WebSocket here. And so the way that I'm actually connecting a WebSocket to something is through an actor. Actors are a great place to put state and then allow me to send messages to the actor so that I can communicate with that state in some way. So what I'm doing here is I have an actor for a user, and the only thing that this actor has in it is this handle to the WebSocket. Then to complete this setting up the WebSocket, I also tell this actor to watch some default stocks, which are defined in my application comp file. So let's go take a look at that actor so you can see what it's doing. So here in actors, user actor.java, these last 2 have been Java just to show you, hey, you can use Java, you can use Scala, whichever one you prefer. So here we go. Here's our user actor where we have a WebSocket connection. And then all that this thing does is it receives a message, or can receive a message, and then we check the message type. If it's a stock update, then we serialize that stock update into JSON and push it out through the channel. And then if the message is stock history, again, we serialize it to JSON and push it out through the WebSocket. So the user actor is really just our bridge between something that can receive a message and the WebSocket that's going to serialize the data and push the message out. So the stock actor is where we contain the state for the stock history. So we have the stock history here, which contains, I think, 50 items for the stock history, just the last 50 items. It also contains a list of watchers. So the watchers are references to the user actor that are watching this particular stock. So if we take a look at what happens whenever we publish a new stock value, what it will do is it first creates the new stock price, it updates the stock history with the new price, and then it sends a message to all the watchers with the stock update. And if you remember back in user actor, when it gets a stock update, it takes that stock update information, turns it into JSON, pushes it through the WebSocket. So this is how we can build up this hierarchy of actors that communicate through messages all in a reactive way, and really, in this case, enabling us to do reactive push. So that's the back-end side of this application. Let's take a look at the front-end side of this application. So let me go back to the main app here. So this page is built in a single-page application style. The UI is all driven through JavaScript on the client. And let me show you how I built that part. So if we go into the views package here, we'll see an index.scala.html. In Play, if you want to do server-side templating, the default way to do that is through using Scala with HTML. There's a number of other templating languages that you can use with Play, but the Scala one is the default here. One of the reasons we like Scala as a templating language is that it's a powerful language, obviously, but also it's type-safe. So just like we saw when if we make a mistake in this file and miscode something, then we're going to see the error messages in our browser right when we hit refresh, just like we did when we did that for the routes file. So this particular server-side template, it doesn't really do anything. All that it does is load in some JavaScript, and that's it. So not super exciting. Let's go take a look at the JavaScript side of this. So this is in app, and then assets, JavaScripts, and index.copy. I chose to write my JavaScript for this application in CoffeeScript. I think the syntax is pretty nice for CoffeeScript. It makes it a bit more readable. Let me just walk you through a little bit of this code. So first, we create a WebSocket. And then we set up a message handler so that when we get a message from the WebSocket channel, we're going to look and see, all right, is it a stock history or is it a stock update? And if it's a stock update, we just add a new element to the chart. If it's a history, we add a bunch of elements to the chart, and that's it. The rest of the stuff here is just setting up charts and doing some DOM manipulation. Of course, you could write the client side of this application with any kind of JavaScript framework. If you want to use Angular or Backbone or anything, you certainly can. I've just chosen to go with raw jQuery in this case. So this is showing really how to build a reactive UI that's being able to listen on the server for messages, react to those messages, and update the UI whenever it gets those messages. So that's a good example of being able to do reactive UI on top of reactive push and on top of the reactive composition that I'm doing with the stock sediments. So that's really most of the code for this application. You can also see the style sheets and how I generate the stock values and those sorts of things. But the tutorial will walk you through the rest of that if you want to see it. Also, you can check out the unit tests in this application and see how we test actors and other various parts of the system. But that's it. That's the reactive stocks application. If you want to dive into that further, just download Activator, unzip it, run Activator, and choose the reactive stocks application as your first template to start with. And the tutorial will walk you through a lot more details than I've done here. And then if you want to go further, learn more about Play or learn more about Akka or Scala, there's other templates in Activator that will help you to do that. So that's how we get started building reactive applications. Before we wrap up and do some questions, I did want to show you another demo that I think is pretty cool to illustrate how reactive scales. Scalability can be a hard thing to visualize, but we have a nice little demo application built in Play and Scala, of course, that shows just how many requests per second we can get in a reactive application. So let me show you that one. Let me go start it up. This is a sample that comes with Play. It's called the Comet Live Monitoring. And I'm going to start this sample up, and then let's go open it up here in our browser. So what you're seeing is a few dials. The first dial is request per second. That's how many requests per second this application is going to get. So what I'm going to do is I'm going to simulate, or not just simulate, I'm going to send a ton of requests to this application, and then we'll be able to see in real time how many requests per second the application is getting. We see memory usage. You'll see that right now I'm at 54 megs. So you'll see that the memory footprint for Play applications is very small. If I tell this thing to garbage collect, then we'll drop it down to 12 megs So really nice that we're not using a massive amount of memory for this application that's right now just sitting and doing nothing. So this application is actually every 100 milliseconds, it's receiving updates through a push channel. So in this case, we're actually using a comment channel, and it's pushing these updates every 100 milliseconds to these 3 dials. So we're getting these messages pushed out. Even right now, we're getting messages pushed out to update the request per second memory and CPU. So right now, not a whole lot going on here. So let's go simulate, or let's go send a bunch of requests. So I'm going to just run this little load test with Apache Bench. I'm going to send 1 million requests to this application. So we'll see that it takes a little bit of time for it to really kind of warm up the JVM. But once my JVM is warmed up, what we'll see is I'll be getting about 20,000 requests per second, and we'll see the memory usage start to fluctuate a little bit, and then the CPU going. But the cool thing about what's going on here is that even while I'm totally saturating this application, this application is still able to be pushing out in real time. Every 100 milliseconds, it's pushing out new values out to the screen. So while I've totally saturated the application, it still is a reactive application that isn't totally crippled under the load and is able to really be able to create a responsive and reactive UI even while there's a ton of load being sent to this application. There we go. All 1 million requests are done. You see my memory usage has dropped back down. So there we go. That's the live comment monitoring sample that you can get with Play Framework. Okay, so let's wrap up. Really, what we're doing is going reactive. That's where software is going. We want to react to events. We want to react to load, react to failure, and react to users. And the Typesafe platform is a great platform for being able to build these reactive applications that do exactly that. Typesafe Activator is the way for you to get started learning how to use the Typesafe platform to build reactive applications. So with that, of course, you can learn more on typesafe.com, but there's been a number of questions coming in, and I want to make sure that we spend some time going over those. So first, there's a question about IDE support. So we sponsor the development of a Eclipse IDE for Scala, which now has some Play support as well. And then IntelliJ, in their free version, has Scala support, and in their commercial edition has support for Play. So both are great options. Really depends on which IDE you are more comfortable with. Personally, I use IntelliJ most of the time, but totally up to you. Both are great tools. There's another question about can Activator be accessed remotely? It's definitely something we've looked into. There technically isn't any reason why we can't support that. For now, we are just being able to do Activator locally as a local running web application. But we've certainly looked at other use cases for running it on your own Amazon server or something along those lines, or to do corporate deployments. So watch Activator. We'll be having more information about that in the future. And feel free to email me if you have specific use cases that you want to discuss or around that. By the way, my email, james.ward@typesafe.com. Okay, let's see. Next question here. Is there a good reason to use Activator with Scala, Play, and Akka instead of server-side JavaScript, such as Node.js? So Node.js is great. It's a great technology. It also has a number of tenets of reactive. The main differences between Node.js and the Typesafe platform is that JavaScript in Node.js is a dynamic language. And at Typesafe, you could guess by the name, we like Typesafe languages, Java and Scala. And so we think that the compiler should do a lot of work for you and help you manage large code bases and help you deal with refactorings and help your IDEs be able to do code completion and all those sorts of things. So we really like Typesafe languages. So that's really one of the primary differences between our platform and Node.js, is that in our platform, you're using the compiler to do a lot of work for you. Also, we're building on the JVM ecosystem and all the tools that exist in that world. And then finally, the other major difference between the Typesafe platform and Node.js is that the JVM supports threads, and so we're able to do multi-threading. We're able to handle blocking by giving it threads. We're able to have some great performance because we have a threading model that we can build on the JVM. Okay, next question. There's a question about compile times. So certainly, one of the trade-offs to having a compiler do a bunch of work for you is that there is some amount of time that it takes the compiler to run. And so, there is a trade-off to that. We've been really doing a lot of work to optimize the Scala compiler and make those compile times as fast as possible. We do incremental compilation underneath the covers, so it does make the compiler run very fast usually. But there's also, once your projects get larger, the incremental compiler has to do more work to figure out what changed. So one of the ways that you can deal with that is to use Play's multi-app support. You can actually do sub-applications within Play, and that really significantly helps reduce your overall compile time and helps the incremental compiler not have to do so much work to figure out what needs to be recompiled. Okay, another question. Is it possible to use Play without SBT? There's a number of parts of Play that are built today on top of SBT. So the routes compiler, the template compiler, and the asset compilers, all of that is built on top of SBT today. So you can, technically, Play is really just the Java library, jar files. You can use those jar files in any build tool that you want, Maven, Gradle, whatever. The problem with that is that there isn't a Maven or Gradle plugin yet to take Play's asset compilers and routes compilers and be able to run those compilers from those build tools. So for today, if you want the full Play experience, the auto reload, all the different compilers that are in Play, then you have to use SBT for that. But if you don't need those other asset compilers, if you just want to be able to do raw WebSockets and JSON, you could certainly do that with any build tool. Okay, I'll take a couple more questions here. And I should mention that if I don't get a chance to respond to your questions, we'll do our best at posting a blog post to summarize some of the questions. And if we don't get back to you or don't get your question answered, feel free to email me, james.ward@typesafe.com, and we'll help you out. There's a question about being able to do war files in Play. And it's a great question. Today, Play doesn't use war files. The reason for that is that we want those really fast development iterations, and then so that's one reason is that to support those really fast development iterations, we can't do the typical container approach. There are some workarounds that we could do, but it just becomes a bit hacky, and so that's one reason. Then when you go into production deployment, there are really easy ways to deploy a Play application, really because a Play application is containerless. All that you need to do to run a Play application is get all your jar files and run them through Java, and that will start up your Play application. So it's a containerless model, but it's not the war model. The war model we know is something that enterprises use often, but we see a lot of enterprises moving away from the container model and the war model because they want to be more agile. They want to support continuous delivery better. And that's one of the core reasons why Play doesn't today support war files, is that we really want to support the containerless deployment, the continuous delivery model. And then another reason is that Play uses some pretty low-level Java NIO networking stuff that's not available in the servlet specification today. Actually, underneath the covers in Play, we use a two-way reactive model where you can actually do network pushback. So let's say that a user is uploading a file and then you're taking that file and putting it somewhere else. You can actually push back through the network on that upload to throttle it for the service that you're actually moving that file to. So that's all built on a two-way reactive model internal in Play, and that's not something that we can build on the servlet model. And so, for today, for now, Play just supports the containerless model of deployment. We've been really successful at getting enterprises to adopt the containerless deployment model. It's just a little bit different model, but if you need help convincing your IT people, feel free to send me an email and I can help you do that. Okay, let's see if there's one more question I can take. There's a question about performance in Play. So with Play, because we're built on a Java NIO model, we're actually able to handle pretty amazing performance. Java NIO is incredibly fast. There's some benchmarks that came out recently where if you look at full stack web frameworks, meaning a web framework that has everything you need all the way from persistence to out to the JavaScript end, really an end-to-end web framework. If you look at performance for those, Play did very well in those. We have customers like Clout who are doing 1 billion transactions a day through their Play REST APIs. So we've had some really good use cases. The case studies on Typesafe.com go into some of the details on our customers that have been successful with really high performance, high throughput Play applications. So yeah, so performance with Play has been great. Unfortunately, we're out of time. I'm sorry if I didn't get to your questions, but we'll do the best we can to get those answered through the Typesafe blog or through email if you email me. Really appreciate you coming. We will be posting this webinar recording on the Typesafe blog and on the Typesafe website so that you can send it to your friends and colleagues. But I hope you learned something. Thank you so much for attending, and hopefully hear from you soon. Bye.